Good afternoon, everyone. Again, this is Corey from the National Weather Service office here in Bismarck. And again, with us here today, we've got Megan Jones, who's one of our climate program leaders of the office. And she's going to give a presentation about the 2023 to 2024 winter outlook. One thing right up the front, I guess, is that if you happen to be on the national webinar, we apologize for if there was any like time kind of overlap there. We scheduled this pretty early in October, so we probably got out ahead of it, quite a ways. So there might have been a little bit of a conflict there, and we apologize if that's the case. If you did happen to see that one, though, we think there's going to be a lot of great stuff on this webinar for you that's more North Dakota oriented. So I think it'll be well worth your time. There will be time for questions at the end of the webinar, so we ask that you hold those. Everyone should be muted at this point. So that's one thing to kind of note, is that if you do have a question, you can raise your hand, and what I can do is I can unmute you, and then you'll have to unmute yourself as well. But one of the real slick things about GoToWebinar, we have this questions box, and I would really encourage you to use that. So you can just go ahead and type a question in there, and what we'll do is we'll make sure that we get those answered for you by Megan. So one thing, again, for our media partners as well, is that at the end, once it's all kind of wrapped up here, Megan is also going to be available to you kind of offline. So all you'd have to do is call the office, and we'll go ahead and take your information, and we'll make sure that Megan gets back to you for any kind of longer length interview that you may want to do. Also, you could just contact Megan directly here. You can see her contact email on this first slide. So just go ahead and jot that down, and you can email Megan, and she'll get back to you that way. So with that, what I'm going to do is pass it over to Megan and let her tell you all about the 2023 and 2024 winter outlooks. Megan, it's all yours.
Okay, thanks, Corey. Thanks for the introduction, and thanks to everyone who is joining us today. Really appreciate it. So yes, we are going to be talking about the upcoming winter. That's what's on everyone's mind. We've been getting questions for a while. And as Corey said, my name is Megan Jones. I'm one of the meteorologists here, but I also specialize a little bit more in climate. So I'm really interested in this sort of thing. And we're just going to jump right in. The Climate Prediction Center put out their new seasonal outlooks this morning, so you may have already seen them, but they're hot off the press. Over here on the left, we have the seasonal temperature outlook, and on the right, we have the seasonal precipitation outlook. This is just for December, January, February, which is the meteorological winter. We know up here in North Dakota, winter lasts a little bit longer than those 3 months most of the time. But you can see in the temperature outlook, there is red shading over North Dakota. This is certainly different than the past couple of winters that we've talked about. So we are favored for above normal temperatures this winter. We are in kind of this leaning above category. Most of North Dakota is in this 40 to 50% range, with down in South Dakota in this 33 to 40% range. And then if we look at the seasonal precipitation outlook, we are also favored for below normal precipitation, which is interesting. And again, these odds are generally in the 33 to 40% range for most of North Dakota, kind of this really light brown shading. But as you get up into parts of western and north central North Dakota, the odds are a little bit stronger in that 40 to 50% range of below normal precipitation in December, January, February. And just for some interpretation of these, it can be really easy to see these outlooks and go, oh, okay, it's red, it's going to be warm. But you really want to think about the probabilities, and they're not as high as you might think just looking at this map. You can get point probabilities on the Climate Prediction Center's website. These are the values for Bismarck, so 41% chance of above normal temperatures for December, January, February, but there is still a 26% chance of below normal, which is, not a zero probability. And then near normal is 33%. So again, it's never, cut and dry. And as we go through this presentation, we'll talk about why these outlooks look the way that they do, and what are some caveats, and why things might not end up the way we think. As we look at the outlooks for the remainder of kind of the winter into the early spring, you can see that we still have those warm probabilities in January, February, March. We lose that dry signal pretty quickly, which is obviously going to be good news for some people, especially as we get late winter into the early spring, approaching the spring plant season. So we do have those dry anomalies at first, but they disappear pretty quickly while we're still holding on to being favored for above normal temperatures. Finally, as we go towards February, March, April, again, we still have those, a slight lean towards above normal temperatures, but you can see that that continues to decrease as we get further through the winter and into the spring. And we still have equal chances of above, below, or near normal precipitation, but it is interesting to see this pretty large area of above normal precipitation favored for most of the rest of the central US. So that's going to be something that we keep an eye on. And later in this presentation, towards the end, we'll kind of touch on what we do and don't know for the spring season. So if you were on this webinar last year, or if you just kind of, are immersed in the weather and climate world, you've probably heard of the El Nino Southern Oscillation. This is the main oscillation we look at for winter outlooks. It's a climate pattern based on sea surface temperatures in the Pacific Ocean, where there's this interaction between the ocean and the atmosphere, and it impacts the entire globe. And there's pretty long predictability for it, which is why it's a main factor in the winter outlooks. The past 3 winters, we've been in the cold phase, which is the La Nina. And so if you remember, especially last winter, being favored for below normal temperatures, that was what we were expecting. But if you don't like winter, this is probably good news for you that we're now in the warm phase. We're in the El Nino phase of the El Nino Southern Oscillation. So we really have a pretty different set of expectations for this upcoming winter. We do have an El Nino advisory in effect. That means that El Nino conditions are occurring and they are expected to continue through the winter. But again, this is, we're talking about the Pacific Ocean. That, it's hard to conceptualize that has anything to do with our winter in North Dakota. I included some of these numbers on this slide just as kind of the thresholds for different El Nino categories. The one I really want to focus on, because you might be hearing this in the news, is the super El Nino. So there's, a weak, a moderate, and a strong El Nino. It's the same for La Nina. Every once in a while, we've only had 3. We get this very strong El Nino, where the sea surface temperature anomalies in this specific region of the Pacific Ocean are at least 2 degrees Celsius above normal. That's a very strong El Nino. It just gets called a super El Nino in the media. So if you hear that, this is what it's talking about. So we have these typical El Nino winter impacts that are very different from what we've seen or expected the past couple of winters. With this winter El Nino pattern, you can see this figure here on the right. We typically get this low pressure in the northern Pacific Ocean, and we end up with, the Pacific jet stream shifts south. So that ends up with a really amplified storm track over the southern tier of the US. So they end up wetter and colder. We also end up with the polar jet stream shifts a little bit north. And so we end up being favored for warmer than normal temperatures across the north central US, the northwest US, and up into the Canadian prairies. The current El Nino that is ongoing is likely with a 75 to 85% chance to become a strong El Nino. And there's very high confidence in El Nino conditions continuing through the winter. It's also interesting because there is a 3 in 10 chance for a super El Nino, and we just talked about that. That is those sea surface temperature anomalies of at least 2 degrees Celsius. So again, it doesn't happen very often, certainly not a sure thing. Right now, we're really focusing on this being a strong El Nino, but it's not out of the question that we do end up reaching that super El Nino threshold. And again, you'll probably be seeing that in the news a lot more just because it is so rare. When we're talking about the probabilistic strength and just the probabilities of this happening, again, there's very high confidence in El Nino conditions occurring. A lot of the times in climate world, we don't have any sort of sure thing just because we're talking about very long lead times and lots of things can change. So this is about as sure as you can get. On the bottom axis, you can see this is the season. So SON is September, October, November. DJF is December, January, February, and so on. And then the percent chance is on the vertical axis. The red bars are for El Nino. You can see for the next couple of seasons, those probabilities are at 100%. And that just does not happen very often, but there is so much confidence, and that's because there are pretty strong sea surface temperature anomalies already. The last I had seen is that we're really already at a borderline moderate to strong event. And you can see these probabilities do start to slowly decrease into the spring season, but by the time we get to March, April, May, we're still at an 80% chance of El Nino conditions continuing. So again, there's very high confidence. We don't see anything else favored until we get to May, June, July, when ENSO neutral conditions start to become more favored, but that's getting pretty far out there. One of the more interesting things I've picked up on from the Climate Prediction Center discussions is that there's really high confidence because those sea surface temperature anomalies are so strong because it's so warm in that part of the ocean, but the surrounding part of the Pacific Ocean is also really warm. So there's a little bit of uncertainty there of, does the difference between the rest of the ocean matter, or will it not make a difference? And it might not, but it is something that's been noted for the past couple months, is that not only is the ENSO 3.4 region really warm, but so is the surrounding Pacific Ocean. And you've probably also, maybe heard of that as well, that the ocean is just very, very warm right now. So of course the question, after you go, okay, we are favored for above normal temperatures, but how much above normal? It could be a little, it could be a lot. These figures are from Brian Bretschneider. He's from Alaska Region Headquarters. This is the average temperature departure over here on the left during November through March. So it's the entire cold season, which is much more representative for us up here in North Dakota, in El Nino years since 1940. So there's 29 events since 1940. The left is the average temperature departure, and then the right is the number of El Ninos with above average temperatures. And it's really interesting to look at both combined. Sometimes you can get some really strong anomalies in the opposite direction that actually can wash out a little bit of the signal if you're just blending all of them together. So looking at the count can actually reveal some really interesting information. So for the average temperature departure, you can see most of North Dakota is in this orange shading, which is +2 to +3 degrees Fahrenheit for November through March, just kind of a general expectation. And then if you look in southwest North Dakota, it's in this yellow shading, which is +1 to +2 degrees Fahrenheit. Okay, so it's pretty consistent across the region. +1 to +3 for really North Dakota into Minnesota, into Montana, and in South Dakota. If we look at the number of El Ninos with above average temperatures, the place that stands out to me the most is actually southwest North Dakota. You can see it's in this orange shading where 21 to 23 of the 29 El Ninos since 1940 have been warmer than normal. That's a pretty good number, honestly, when you're thinking about the record as a whole. And again, the problem with climate is that the sample size is not that high normally. So 29 is okay. It's not great, but it's okay. But 21 to 23 out of the 29 in one direction is going to make you think that it's a pretty good probability that we end up with, above average temperatures. It's not a guarantee, of course, but those are pretty good odds. If you had to pick a category, you would pick above average. If we look at the rest of North Dakota, most of it is in this yellow, which is 18 to 20. So again, more than half with above average temperatures. A few small areas a little bit lower in that 15 to 17 category. So again, you can look at the average temperature departure, but you can also learn some things from looking at the count. As we look at precipitation, this is just December through February, but again, in those El Nino years since 1940. On the left is the percent of average precipitation, and on the right is the number of El Ninos with above average precipitation. So we're going to be, you kind of have to think about that for a second, just to see, is it are more above or are more below. But what stands out to me just looking at the percent of average precipitation is looking at western North Dakota, and then the small part of northeast North Dakota is in this gray shading, which is actually close to normal, 95 to 105% of normal for precipitation, which is, probably good news for a lot of people. We never want to be, getting too dry at any point in the year. Most of the rest of North Dakota then is in this yellow shading, which is 75 to 95% of normal. So again, not incredibly dry, but certainly a tilt towards drier than normal conditions. And then if we look at the number of El Ninos with above average precipitation, again, western North Dakota is what stands out to me. There are a few pixels that can be kind of hard to see of green, which is 15 to 17 of above average. So then kind of the opposite, it's about 50-50 above or below, which again would put us kind of close to near normal for western North Dakota, not really a tilt one way or the other. But then if you're looking at the rest of central and into eastern North Dakota, we start getting into these yellow shadings where there's not too many El Ninos that have above average precipitation, especially some in this yellow, which is only 9 to 11 out of 29, which tells you that the rest of them had below normal precipitation. So there is certainly a tilt towards drier than normal conditions overall for El Ninos. Finally, if we're looking at seasonal snow, after last winter, I'm sure that is what is on everyone's mind. We don't want a repeat of that, at least most of us don't. Looking at seasonal snow, the percent of average snowfall is over here on the left, and then again, the number of El Ninos with above average snowfall is on the right. You can see there's a pretty consistent trend across really our entire region, North Dakota into northern South Dakota, Montana, Minnesota, all in this yellow shading of 75 to 95% of normal. So again, you know, not zero, but certainly a tilt towards below average snowfall. If we're looking at the numbers, it's interesting because, you know, if you're looking at the percent, everything seems very equal. But if you start to look at the numbers, you can really see this area in the northwest in this orange shading. That stands out the most to me. That's only 6 to 8 of these 29 El Ninos with above average snowfall. So that tells me that most of the time, this northwest part of North Dakota, kind of into the central part of the state, most of the time they have below average snowfall. So again, you know, overall dry, but there are some parts of the state that are maybe more frequently seeing below average snowfall compared to other parts of the state. So I love these figures. These are from the Science and Operations Officer at the Tucson office. So shout out to Tom Dang. I really like these because it illustrates how tough this can be. We are looking at El Nino events, the temperature anomalies, and we're going to focus on these strong the strong events, which is up here on the top, these 8 events. And you can see that overall, you know, most of the time you get that warmer than normal. You can see that 5 of the 8 have really strong warm trends. One year, 1972, 1973, was pretty near normal. And then you have these 2 years, most recently 2009, 2010, where temperatures were below normal. And it really illustrates that we can go into winter with this expectation. And a lot of the times it comes true, but not always. And I think that's the hardest part of trying to do a winter outlook, is that we can expect what we normally see, but it's never a guarantee. This is the same sort of figure, but for precipitation. So again, focusing on these strong El Nino events up here on the top, these 8. Again, you do see there is, you know, definitely a tilt towards below normal precipitation for December, January, February, maybe a little less spatially consistent compared to the temperatures. But there are these 2 outlier years, 97, 98, and then 2009, 2010, where almost all of North Dakota was very consistently above average precipitation. So again, there's an expectation in what we typically see, but it's never a guarantee, and sometimes we do get the opposite. One of the interesting things when I was really diving into the data for this presentation was just trying to see what we could get besides just the general winter outlook. It's interesting going directly into an El Nino from a La Nina. That does not happen too often. Typically, the ocean and the atmosphere need a little bit of time to transition from one to the other. So there's only 6 comparison years. So again, sample size is very small, but I thought it was interesting enough to look at. So you can see the seasons over here in the leftmost column. We have the first snow of at least 1/10 of an inch. We have the December, January, February snowfall, the seasonal snowfall, and then the December, January, February temperatures. All this data is for Bismarck. It just has, you know, the best snowfall record. So I try to always, you know, not just pick Bismarck all the time, but for snowfall it is easiest. You see these 3 years with the 2 stars. Those are the years with a strong El Nino. It's worth noting we've never had a super El Nino directly out of a La Nina. Again, I said earlier that there's a 3 in 10 chance of getting a super El Nino. So if we, it's not guaranteed, but if we were to end up with that, we would really be in uncharted territory, so to say. So that would be very interesting from a climatology sense. But again, if we're looking at these 6 events, there are some patterns that emerge. DJF snowfall is evenly split, 3 above, 3 below seasonal snowfall. We end up with 2 years with above average seasonal snowfall compared to 4 below. But what really stuck out to me was that December, January, February temperatures were either below normal, which was not expected, or they were just near normal with this average. So again, you really lost the warm signal that we typically see with an El Nino, and that could be related to being directly after a La Nina, which is when we are favored for below normal temperatures. Again, sometimes the atmosphere just takes a little bit longer to reset than we're thinking when it's directly coming from a La Nina. Another thing to look at is all of these strong El Nino years. So we just looked at those figures where it showed, it had the little boxes and it showed each of the years individually. Same years, just a different way to look at the data. So we have our 8 strong El Nino years since 1950. These years with the little arrow, those are the El Ninos directly out of a La Nina, so what we just looked at. And then the years with the stars are the 3 super El Ninos. The most recent one is 2015, 2016. Again, we have our first snow of at least 1/10 of an inch. It's normally earlier than normal with a few, really just one exception. What really stood out to me here was looking at the DJF snowfall, that 7 of the 8 years were below normal, except for this one, 2009, 2010, which is an outlier in a variety of ways. We then go to seasonal snowfall, and we did pick up one year, 1991, 1992, to end up above normal, but otherwise the seasonal snowfall was below normal 6 of the 8 times. And it is worth noting that the highest here was only 57.5 inches. And when we looked at the last slide at all of those El Ninos directly out of a La Nina, the highest was only 60.3 inches. So again, we're not even close to what we ended up with last year when we're thinking about really the highest that we're seeing in most of these El Nino events. It was also interesting looking at the December, January, February temperatures. You can see these 3 outlier years are the 3 that were the El Nino directly out of the La Nina. Otherwise, very consistent that we end up with those warmer than normal temperatures in winter. So again, one of the things I kept seeing is that these years with the higher totals were really dependent on snowfall outside of December, January, February. So we're really going to be focusing on those transition seasons, which can be a little tough for us, especially as we're looking into spring. And again, we'll talk about that more here shortly, but just very interesting things to look at where, very dependent on transition seasons. And I think we've seen that the past couple of years that it just takes one really big winter storm to really jump up our seasonal snowfall totals. So of course, there's a lot of other things that can play a factor. Plenty of different oscillations and other things going on in the atmosphere. And of course, these just have shorter predictability. And this is where it gets really hard when we're talking about 3 to 6 months from now. The main things we have to go on are the El Nino Southern Oscillation and long-term trends. I'm sure that all these oscillations at some point this winter will play a factor, but we can really only see them on kind of the 2 to 4 week time scale. So unfortunately, just not too helpful at this point in time. The one oscillation we are at least looking at right now is the Pacific Decadal Oscillation. We have done some local research here at NWS Bismarck that shows that a negative PDO, which is the current condition that we're in, it can limit the influence of an El Nino. An El Nino with a negative PDO, it still has overall positive temperature anomalies. It's just much weaker, especially during February, which is interesting because February, in terms of climate trends, also has a really strong cooling trend. So that's the month where if we're going to get, really cold, it's probably going to be during February. And I think if you've lived here long enough, you would agree that that is typically when we get those really cold outbreaks. Our warmest winter seasons occur during El Nino and a positive PDO. So that, kind of makes me think that maybe we won't get like that really, really warm El Nino winter. It'll still be warm, just not nearly as warm, considering we have that negative PDO kind of limiting the influence. So the springtime concerns, there's already been questions about spring, which is totally fair. That's an important time of year for a lot of people. Spring is tricky. If there was any season that I was really unsure of going into this presentation, it's spring. And that is because the El Nino, that warm signal typically lingers, decently well into the spring season. But it's going to be competing with some really strong cooling trends. And this figure on the right, this is just the difference between the 1981 to 2010 and the 1991 to 2020 climate normals. And this really stood out that there's a very significant cooling trend in the north central part of the country. So again, it's one of those where we don't quite know which one is going to dominate. We've seen so far in this fall, we were actually not expecting quite as nice of a fall as we've seen. So the long-term trends have actually been dominating this fall compared to the influence of the El Nino. So hopefully in another couple months, we'll be able to have a better idea of what we're expecting for the spring. But this is really the season to watch, I think. Of course, here is the March, April, May outlook. Again, it's interesting. They are hanging on to that warm signal just a little bit. But it's certainly diminishing. And then, of course, equal chances for precipitation. But again, that wet signal in most of the rest of the central CONUS is very interesting to me. Again, I think we've seen the past couple of years, we can get some pretty big late season snowstorms. So that is going to be something to keep an eye on as we go through the winter and into the spring. Other springtime concerns, this is the latest drought monitor that got released this morning. There is still severe drought D2 ongoing across parts of north central and northeast North Dakota. A concern that our hydrologist actually brought up is that, if we end up with below normal snow and we have a shallow snowpack going into the spring, that could lead to further degradation of drought conditions in the spring. We're very reliant on that snowpack and that melt to help replenish soil moisture as we go into spring plant. If we don't have a very robust snowpack, that could certainly have some impacts in the spring. And that could also potentially lead to a more active spring fire season. Again, these are never guarantees, but they are things that we are just starting to think about as we go into the winter season. So kind of to summarize all of this, for what we're expecting, temperature, I didn't show the CPC outlooks. They are equal chances for both temperature and precipitation for November. Which is about what we are expecting, is that, kind of a near normal remainder of the fall. Not expecting that transition from fall to winter weather to be as drastic as it was in recent, the past couple years where we had the La Nina. I keep thinking about last winter when Halloween was super nice, and then a week and a half later, we had 18 inches of snow that didn't disappear until April. That is not what we are expecting this year. It should be a much more gradual transition with those warmer than normal temperatures favored in the winter. For temperatures in the spring, again, that's where it gets really tricky. That warm trend starts to weaken as we go into the spring. Still favored, but again, those long-term trends with that really strong cooling trend in the spring is certainly something to watch, where winter might hang on a little bit longer than we're expecting. As far as precipitation, El Nino events skew towards lower than normal snowfall, really dependent on those warmer than normal temperatures. And again, that's where there can be differences between precipitation and snowfall, where if we end up warmer than normal, we could actually still see precipitation close to normal, especially in western North Dakota. That could lead to us having more mixed precipitation events, which is a zone set of hazards. But based on previous winter seasons with a strong El Nino, our guess, and again, take this with a grain of salt, my guess last winter was pretty rough, let's be honest. But for Bismarck, we're guessing 40 to 55 inches of snow and then slightly less in western North Dakota. And I'm thinking that we can end up very dependent on springtime snow for seasonal totals. Again, if we end up staying a little bit cooler than normal and maybe getting a little more active towards the end of winter into the spring, it only takes one storm to really bump up our seasonal snow totals. And finally, for some fun bonus content, this is really exciting. Our Science and Operations Officer, Chauncey Schultz, actually made a local machine learning model. He used AI to train a random forest model to predict the season. A bunch of factors, including ENSO and PDO, so things that we've talked about. So it's brand new for this season, so this is our first guess. But it's interesting because the seasonal snowfall, it puts the chance of above normal seasonal snowfall at 59%. But then December, January, February snowfall, a 63% chance of below normal, which again would mean that we're going to be pretty dependent on our transition season snowfall to if we do end up above normal. Also interesting to see a 65% chance of above normal temperatures in December, January, February, when we are favored for above normal temperatures with the El Nino ongoing. So again, we've got some guesses. Stay tuned for the winter season to see what happens. But I know that was a lot of information. I'm happy to take any questions, whether in GoTo or again, here's my email address, and that's also our office phone number. You can reach out to us at any time. So yeah, I will turn it back over to Corey to see if there's any questions.
Awesome. Lots of great information there, Megan. So like Megan said, what we're going to do now is go ahead and open it up to any questions that folks might have. So far, I'm not seeing any questions in the questions box, and I'm not seeing any hands raised either. If you are a media member, again, you can definitely contact Megan after the webinar. You can either call the office and we'll make sure that we take a message and have Megan get back with you, or you can send her an email at the email address here on the slide, and then Megan will get back with you and she can give you kind of a personal one-on-one discussion of any of the questions that you might have. So just kind of looking again, still, okay, Andrew, I see Andrew Kirkin, you've got a question with your hand up. I'm gonna unmute you, and you still might have to unmute yourself, Andrew.
All right, am I coming through?
You are.
All right, thank you guys, everything you did with this webinar. And I've been listening in between spotty cell signals, but kind of my takeaway from this is you're favoring a dry winter. And really, if we want our farmers to have a chance, it might be next spring to get that good precip event. Is that about right?
Yeah, that's certainly kind of the general thought right now. And I feel like my thought changes like every week as we kind of get more and more data in. But it is interesting to see that there's definitely a dry signal to start the winter before it really diminishes later in the winter. And again, I think we've seen, the past couple of springs, just as we stay colder for longer, that we do end up getting those late season, snow events that are more beneficial for the farmers. So again, that's where it can be kind of hard talking about an entire season, but even if we start out dry, I wouldn't totally give up hope that it's going to be really dry going into the spring. Winter can be pretty long up here, but just on what we're seeing so far, I would definitely expect a little bit more active as we go into the second half of winter and into the spring. Thanks for the question.
Well, after last winter, you're breaking a whole lot of hearts. Happy to hear it, and thank you your team.
Thank you.
Awesome.
We appreciate it.
Yep, thank you, Andrew. We appreciate that. Got a question from Frank Ballack, and I was going to mention this at the end. So thanks for the question, Frank. It says, will the slides be sent out or a link to the presentation provided? And the answer to that is yes. We're going to be sending something out after the presentation. I think it's going to probably go out tomorrow, though. The reason for that is that the recording sometimes takes a little bit to kind of get finished up and everything. So look for something in your inbox. I think right now the plan is tomorrow, unless Megan corrects me on that. Also, I think we're going to have some thoughts of perhaps putting something on one of our social media channels. So you'll probably see something on Facebook and X/Twitter at some point tomorrow. It'll probably be a little bit of an abridged version of this presentation on the social media channels, but there are going to be some thoughts to provide something there. So if you wanted to share it out that way as well. Megan, do you have anything to add to that?
No, that sums it up perfectly. Yeah, look for an email tomorrow with both the slides and the recording. And then, yeah, as Corey said, we're hoping to get some shorter but still useful information shared on our social media and also on our webpage. So keep an eye out for that.
Any more questions from anyone? I don't see any other hands raised or any other questions in the questions box. So I think what I'll do is just kind of give it another few seconds here. And what I'll do is I'll take the opportunity real quick to mention to everybody that Severe Winter Weather Awareness Week is coming right up. As a matter of fact, it's October 30th through November 3rd. So that's something else to kind of keep on your calendars. So again, Severe Winter Weather Awareness Week, October 30th through November 3rd, and there's going to be a lot of great information on our webpage available on there. Comment from Kimberly Robbins saying she appreciates the briefings and wondering if another could be sent in December as an outlook for the El Nino status. So how do these generally get updated, Megan, would you say? What's generally done with that?
Yeah, so the Climate Prediction Center is always updating their seasonal outlooks and their ENSO status. Once a month, the seasonal outlooks get updated the third Thursday of every month, and then the ENSO update is the second Thursday of every month. But we can certainly send out something locally as well. Later on in the winter, as we're getting a better picture of what's going on, if that's something that's wanted, that is certainly something that we can do.
Looks like Sarah Dutenhefner has said, thank you for a great session and looks forward to getting the information. So great comments there, Sarah. We appreciate that. I'm not seeing any other hands raised or no other questions in the questions box. So I think with that, I'm going to go ahead and say thanks to everybody for taking the time today to attend the presentation. Again, look for the emails from Megan and don't hesitate to reach out to Megan if you come up with any other questions after the fact here. So thank you so much, and thank you, Megan. We appreciate it.
Thanks, Corey, and thanks everyone for attending.